Third day in Chapter 5. We've been taking derivatives of natural logs. Now what we're going to do is we're going to work on integrating problems involving natural logs. Okay, so we're reversing the process. What I want to start with is, we've just gotten done taking the derivative of some of these natural log problems. Let's start with this. If I gave a problem, like the integral of 1 over x dx, for what we know, for being able to go through and take that antiderivative, we would probably start by doing this. Now, if you follow your rule, your power rule, add 1 to the power, divide by the new power. I'm hoping that right now you recognize why we can't integrate 1 over x the same way that we do everything else. So this isn't going to do anybody any good. So this power rule is not going to apply to things that are inside, this theorem. So what we're going to have this time instead is we're going to need a special rule. Well, when we took the derivative of natural log of x, when we took that derivative, we said, hey, you know what? What's the derivative of natural log of x? That derivative, 1 over u times du over dx. Well, what are we doing this time? We're reversing that process. This time we're going to take the antiderivative of 1 over u du. So that's going to end up to be natural log of the absolute value of u plus my c. Natural log, absolute value of u plus c. Why do I need the absolute value? I need the absolute value because you're introducing a log into the problem, and we can only take the natural log of a value that's positive. So what are we going to do? So problem number 1, here we go. Now I've got a constant here like this 2. So if I have a constant 2, I'm going to write it outside the integral before I start. So here we are doing that one that I had to cross out with the green X just a few seconds ago. So now what do I have? Well, I have that blue 2 times the natural log of the absolute value of that X that's on the bottom plus my C. Now you could certainly rewrite that. You could call that thing instead, you could call it natural log of X squared if you wanted, put it up as a power. And then if you did that, if you squared the X, you wouldn't need the absolute value anymore because it would make your values all turn out positive. This is a perfectly fine place to stop, but this one would work also, and those log rules are still going to apply to all these problems that we do. Second one. Well, what do I have this time? Well, this time I see 2 terms on the bottom, 4x and 1. Can I do anything about it? No, because you can't split the denominator of a single fraction. So I think here, this looks like one that we might want to try our old standby, which is our u substitution. So let's say we made u 4x minus 1, and then du would be 4 times dx. So the dx that's written in the problem would be the same as 1/4 of a du. So rewriting this integral now in terms of u instead of in terms of x, I would need a 1/4. And then I would be integrating a fraction with a 1 on the top. The denominator would be u, and I would be integrating with respect to u because there's my 1/4 du in place of the dx. Well, now 1 over u, we've just learned. Integrating that, we can't do power rule, so our last resort would be, let's play around with that natural log thing. So I've got 1/4 times the natural log of the absolute value of that u plus my c, or 1/4 natural log, don't forget to put your u back in, 4x minus 1 plus my c. So, and yes, you could move that, pardon me, that 1/4 up to make an exponent out of it, but I think we already did that, and if you want to, you can, but you don't need to. 3. And what happens this time? So again, I see multiple terms in the denominator, so I'm not going to be able to split it, I'm not going to be able to change it. So I'm kind of feeling like maybe this is another one where if I'm out of options, I should probably try u substitution. So let's try it again. So let's say u is 4x squared plus 1. So then my du would be 8x times dx. So what do I have in the problem? I don't have 8x, I have 4x, but you know what? I'm just going to isolate the x dx in this equation. Well, the x dx that's in the problem could be replaced by 1/8 times du. So up here I know I have, wait a minute, this 4 up here on the top, that's going to be a constant. So let's bring that 4 along for the ride. And then we're going to be introducing a 1/8 multiplied by that 1/8. And then we've got our integral, and that 1/8 du. And then in my integral, the x dx is already accounted for. So that's a 1 on the top, and the denominator looks like it would have to be my u. So now what I really have is I have an integral that has a 4 and a 1 times a 1/8 out in front of it, which is a 1/2. Antiderivative of 1 over u is natural log absolute value of my u. Pardon me, plus my c. What's u? U is 4x squared plus 1. And we could move the 1/2 to make an exponent out of it if we wanted to, but we don't necessarily have to. So pretty good start there as far as integrating problems with natural logs. Now we'll get to the integrating problems with long division in a couple seconds. I want to do one more integrating with natural log. Here we are again. I've got multiple terms in the denominator. I've got a single term in the numerator. I don't think I'm going to be able to change the problem other than maybe trying to rewrite it. So that's what we're going to do. So we'll say u is 4x squared plus 1. Pardon me. So du would be 8x dx. Well, let's see. So the x dx that's in the problem, this is going to be a lot like the one we just did, it looks like. 1/8 du. So I've got a 4 up here again. That looks like it's going to be my, my constant that comes along for the ride. But this time then I'm going to introduce this 1/8 and this du into this integral. But this time with the integral, on the top it looks like everything was accounted for, so I'm going to throw 1. But on the bottom this time, we've got u being squared. Well, wait a minute. If u is being squared, then it's not a natural log. Now, the issue that people are going to have, the mistake that people are going to make, is they're going to think that this thing means as soon as we see this, 1/2 of the integral of, wait a minute, that's going to be a natural log. This isn't a natural log. This is integrating, pardon me, u to the -2 du. Well, now if you go to integrate that thing, don't try to force a natural log in every problem. Trust what you know how to do. Well, we knew how to do power rule before we started watching this video, so let's try to do power rule again. 1/2, add 1 to the power, divide by the new power. Don't forget c. So if we do that, it's going to move the u to the bottom. We're going to have a 2 on the bottom. We're going to have a negative. How about -1 over 2 u plus my c? What's my u? Well, this u that we had in here all along was at 4x squared plus 1. So there's some integration that involves natural logs. Now, this last one wasn't a natural log, but I'm going to tell you that over and over and over again, we're going to have students that are going to try to force that one to be a natural log problem. So be very careful. Be wary of forcing every problem to have a natural log in it.